So now that we've investigated a little bit about the cout object, it's time to start talking about other portions of the programs that we're going to build. And what we'll start with is identifying what a variable is, what an assignment is, and what a literal is. This is 2.4 in your textbook. It goes from pages 38 to about 41, and I will highlight what we're talking about here in the text rather than build a working REPL around this. So first of all, we have the idea of a variable. A variable is something that we know we have identified that we'll need over the course of a program that has the ability to change its value. Now, a couple of things about variables. We will talk about the different data types here as we go through chapter 2. We have an integer here in the example in 2.4. But there are other cardinal and other data types outside of the cardinal data types that we'll talk about here, frankly, shortly. So what is important to know is, like we see here on page 38, when we are declaring a variable, like here on line number 7, you can see it, int number. This is a variable declaration. What we are telling C++ is you need, please, to set aside a bit of storage. So a variable really maps to a location in memory, and that location in memory is going to be of type int. So what that does is it tells C++ how big a storage location it's going to need. We also give it a name. You can see here that is called number. So when we reference number, what we're really doing is telling C++ to reference a location in memory of type int, and its name to use is number. Now, we haven't put anything yet in that location in memory. It is simply set aside for us. So what we need next is what is referred to as assignment. That you can see right here. This is still on page 38, just a little bit lower down. We have number equals 5. So now what we're doing is we're telling C++ the area in memory which we are referencing, which we are calling number, we are going to give to it the value 5. So that is an assignment. Now, we could also have combined these two statements by saying int number equals 5. So that is a declaration and an assignment in the same statement. That is perfectly all right too, although there are times where you're not going to be able to necessarily declare and assign in the same statement. That might, well, it 100% will show up later in our examples here. So you can see, if we keep scrolling down, something to be aware of here, where we say number equals, and then, like we have mentioned before, anytime you see those double quotes like that, we're referring to a string for us. So number equals 5 in double quotes like that is not the number 5. That is going to be the ASCII representation of the number 5, which off the top of my head, I do not know what it is. So that's not the same thing. We're going to spend a lot of this chapter talking about types of data, integers, doubles, strings, etc. And this is a type mismatch, integer and string. So the result there is not going to be what you expect. We will see this for sure when we get through and talk about strings. The very final concept we have here in 2.4 is the idea of literals. This is on page 39. A literal is a piece of data that we hardwire into the code someplace, and it can take essentially two forms the way that we are going to do it. First and foremost, we can say number equals 100. So here, whenever we refer to number, what we're doing is we are talking about a literal, and I'm going to scroll you down right here to tell you about what type it is. That is on page number 40. When we give the number equals 40, what we are doing is we are giving it an integer literal. We're saying literally when we refer to number, you are referring to the value that we store there, and that is 20 in this case. We also have what are referred to as string literals. It's really just a string that we output to the console. So here you can see in double quotes, today we sold. That represents a string literal because it's something that we have hardwired into the code to output. And bushels of apples, that's again a string literal. That is something that we have hardwired into the code to put into our output console. So literals are called constants because we have to go through in the actual code and change them outside of the runtime environment, outside of the compile environment. That has to be done when we are writing code. So they're called constants because once we're running, they cannot change. So assignments, we can see if we scroll or flip, variable assignments and declaration, rather, we can see right here on page 38 again, int number. That is a variable declaration. An assignment we do with the equals here. So number equals 5. I can combine those two statements. Int number equals 5 is a declaration and an assignment all in the same one line of code. The very last thing we have here is the idea of a literal, something that we hard code. So number equals 100, this is a literal because I am referring to the value 100 every time I use its literal, and that is number. Or this is a string literal. This is page 40. So inside of the double quotes, welcome to my program, that is a string literal. Literals are also known as constants because we have to hardwire them in there. There is no changing of a constant during the run of the code.